All right, let's try this one again. Third time might be a charm, and let's turn on the microphone this time. Hey, there's all the stuff I was just talking about. And let's start over. You know what a new page is going to be the way to go. That's adding a photo. Hey, could have just went down. Okay, let's try again. This will be your intro to logarithms. Let's get rid of U. So to talk about logarithmic functions, we're going to start off talking about exponential functions as they are related. That's going to bother me. Got to do that again. We'll look at the exponential function 2 to the x. So if I make a table of values, 0 is 1, 1 is 2, 2 is 4, 3 is 8. Do some negatives. Negative 1 is 1/2. Negative 2 is 1/4. So we start graphing 0, 1, 1, 2, 2, 4, 3, 8. Just keeps doubling. Negative 1/2, negative 1/4. So this is a pretty good look at an exponential growth function. It's growth because our factor is bigger than 1. We're multiplying by 2. Our initial amount is 1, just as a little review. Remember that we have a horizontal asymptote at 0. Yeah, and that's a little reminder of our exponential functions. What's interesting to note about them is that they're functions, so they pass the vertical line test, but these exponential functions also pass the horizontal line test, which means their inverse is also a function. So since we're studying functions, let's go ahead and study the inverse. So how do we build the inverse? We should flip the x and the y values. Let's start there. And let's graph those and have a look at what this thing looks like. That was a terrible line. Try that one again. That's not really any better, but we're going to go with it. So 1, 0, 2, 1, 4, 2, 8, 3, 1/2, negative 1, 1/4, negative 2. So the graph looks like that, sort of. Let's see here. We have an asymptote here, but this time it's a vertical asymptote at x equals 0. So that function right there, that's the inverse of the exponential function. If I plot that thing on the same set of axes, you can see I'll put its vertical asymptote. You can see that it is, what color do I want to go with? Green. A reflection about the line y equals x. Okay, so that kind of shows graphically that it's an inverse. We saw on the table that it's an inverse. The question is, what about its equation? Well, that's its equation, right? We switch the x and the y. But since it's a function, we always say, like, let's solve for y and write it in function notation. So y equals what? Well, that's where we have to make up some new notation and talk about naming this thing. So mathematicians named it a logarithm. They use log for short. And a log has a base whenever you write a log. So that's the base of the logarithm. Then it's of something in parentheses, so it's a log of. So I don't know, I'll just call this a k for now. All right, so the way you read this is log base b of k. And you need to think of log or a logarithm. One way to think about it is that log is an exponent. Okay, so when we're evaluating logarithms, you could think of it as like, what is the exponent? Okay, let me show you an example of that. Evaluate log base 2 of 8. Well, if you think of log, and so it's going to equal something. So what does that equal? Instead of a question mark, I'll put a variable. We want to know what x is. So it's almost like, well, it is solving an equation, right? What is that expression log base 2 of 8 equal to? So if you remember that log means exponent, it's like a question. What is the exponent, that's log, what is the exponent of base 2 that would equal 8? Well, you just sort of know that that answer is 3. Okay? So the way you would write that, that's log, this is logarithmic form. The way you would write that as an exponent is like 2 to the base 2 to the power 3 equals 8. And that shows us how we can write back and forth from exponential form to logarithmic form. Okay? So we'll try another one. Log base 10, which is called the common log. Log base 10 of 10,000 equals, we want to evaluate that expression. So it's really saying, like, what is the exponent of base 10 that would equal 10,000? So remember, that's what log means. What is the exponent of the base 10? So you can see that that's another way you can look at writing it in exponential form, okay? And there are 4 zeros there, so that's going to be equal to 4. So this expression, log base 10 of 10,000, is a number, just like this expression is a number. Just like this expression is a number. Okay, this is another mathematical expression. Log base 10 of 10,000 is equal to a number. It's equal to 4. It's saying what? It's answering the question, what is the exponent of the base 10 that equals 10,000? So back to, how do we rewrite this guy here? Well, we know we want to write log, need an O in there. What's the base of this? If I'm solving for y, the way you solve for a variable when it's in the exponent, which it is, the y is in the exponent, how the heck do we solve for that? That's called an exponential equation. Rewrite it as a log. So if I'm rewriting it as a log, I write log. What's the base of the log? Well, it's the base of the exponent. So log base 2 of x equals y. And you can see now I've solved for y. So that's how you write the inverse, okay? Remember, this means what is the exponent of base 2 that equals x? So that's what's going on over here. 2 to what exponent? Y equals x. So that's how you rewrite it, just like we did here below. It made more sense here, right? Because there was numbers. That's how you write the inverse. So the inverse of y equals 2 to the x. If I switch the x and the y and find the inverse, I get y equals log base 2 of x. So this function and this function are inverses of each other. It's called the logarithmic function. Sometimes the exponential function, by the way, has been called the anti-log function because it's like the inverse or the opposite of a log. That's your introduction to logarithmic functions.